All right, welcome everybody, Ontology Tradecraft. This is effectively the last lecture that I will be giving this semester. Subsequent, we'll be doing student presentations. So it is only fitting that I'm under the weather. A little cold. Hopefully you can understand me through the mask. I will do my best. But so some conversations that I've had recently with folks in the class have suggested that I should put a little emphasis here on debugging. And so you'll see today at the second half of the lecture, I'm going to talk a bit about debugging in general and then debugging using LLMs. It'll be right in line with the use of LLMs in the final project. I did update the most recent or the final project, so you have in a README a description of what I'm expecting. I covered it last time. You got a couple of options, one on mapping, one on your semantic pipeline, extending it to new data, new design patterns, and the other one on mapping. The first part of today's discussion, though, I did want to kind of hit on some more recent mapping discussions, in particular ones that were had at a special summit of the IES and BFO meeting on Friday of last week, bright and early in the morning. At least one of you was there. It went well, but I learned some lessons that I think I will pass on to you today. And so with that, uh, I guess before I jump in with all that, I mean, you got the overview here of what we're going to talk about. Mapping first, debugging, general principles, debugging LLMs. Any questions, comments, concerns, compliments before we get started?
Yeah, sure, John.
Sure. What you got?
Um, I've been digging in the last project,
Mm-hmm.
and I found like just to get things working smoothly, I'm sort of really working my way up. I'm saying like let's suppose I'm starting to create an ontology from scratch,
Uh-huh.
because I think that mapping is sort of creating an ontology from scratch plus extra constraints. Namely, you have sort of the definitions, you have to work within. How bad is that as in performance wise? Because I think I'll get to the mapping part. I have now sort of some prompting going on, code generation, ontology generation. I can check that, I can verify that, but it's more like assisted ontology generation than anything else.
Yeah.
Is it very bad if it sort of turns out that that's it? I mean, I intend to put a week more extra work in it. So
I mean, it doesn't sound bad to me. Like I'm thinking in terms of deliverables, right? So if many ways to cut the pie, many efficient ways to cut the pie, many inefficient ways to cut the pie. And we're sort of on the edge of research here. So like I'm happy with an exploration style mentality. So let's just say, to put this in other terms, let's just say you take a stab with this approach at like hitting the deliverables I've described, and it fails miserably. We've learned something very important, right? And that's valuable, especially as we're on the edges here. So, what I'm going to do now is shift into my natural disposition, which is cheerleader. So do it. Like, let's do this. I want to see it. I want to see the upshot. Go forth and go on. I'm happy with that. And this is the same for anybody's projects, right? If you're approaching something in a way that's different, say, from the way I'd suggested, that's fine. I'm happy for that. I feel like if you muscled your way through the class up to this point, you can do that, right? If you've been tracking along, I've dragged you through some things. You've seen some stuff. You might disagree with how to approach it. That's fine. Go forth. Let's do it. You might be right.
great, thanks.
Yeah, absolutely. We've got in the chat here. Obituary. Now I was thinking like a post-mortem. That's what I was thinking of. Other comments, questions, concerns, etc.
Yeah, John, I have one though. You can tell me that we could talk about this later. Just about Project 5, I was able to execute like a full pipeline
Mhm.
and I don't have to like touch it or anything, and it'll go ahead and move on its own.
Right.
Um, but I found that because I chose the facility module, it potentially just isn't adding any axioms. Like at the end of it, it's just like we're not adding anything, but it works. And I'm just like, well, that's cool. But and I was just wondering if you had time to answer that now, or if you again, if you want to push that for later, that's fine.
So let's revisit that at the end of this because we'll have time to debug some stuff. So we're gonna do like a live debugging. at the end. It's not number 4 there on the bullets, but that'll be effectively number 4. And so what we're going to do is you pose questions. I show you how I would how I would debug them.
Got it.
So this seems like a ripe one. So
Sweet.
All right. With that in mind, let me jump into ontology mapping revisited. So, all right. When I think of ontology mappings, I think these things matter most where correctness and invariance and interoperability are not really optional. Like you need very refined formal constraints to tell you when you're talking about the same thing across different structures. And I'm putting this in terms of ontology mapping, but this is of course general schemas, knowledge graphs, whatever, semantics, like refined semantics that go from one structure to another, refined logic or formal representations that go from one structure to another. That is key, and these are most useful when that's kind of correctness is not optional. In a sense, ontology mappings provide a guarantee the systems using the mappings can meaningfully reason with or transform or integrate one another's data. It's not a thesaurus. It's a bridge between commitments, ontological commitments. I also think of these as best used in application. Ontology mapping files, say, don't, to me, they don't matter on their own. They're not ontologies. They have different standards for whether they're useful or not than ontologies. You don't have to be a purist about ontologies. So, I'm saying this explicitly because in the history of the field, people will take, like, say, gist BFO and create a mapping file from, say, gist to BFO or BFO into gist. I'm just taking an example from a recent discussion. And they will then discuss whether, the mapping from gist into BFO is aligned with like BFO principles. It's like pure BFO or something like that. I think that's not exactly the point of a mapping exercise. I think what that gist BFO file is useful when you're thinking about when you need to flip between representations in a specific application. And that is more of an implementation question than an ontological purity question. So this, as a matter of fact, came up at Force when when presenting the gist BFO mapping. There were a lot of folks in the community who were like, oh, I don't know that this would like align with the principles of BFO, this thing that you've created, this ontology, quote unquote ontology that you've created. And I was in the audience going, different criteria of success. Like how you use it in an application is key for mappings. And so same here for IES and BFO mapping. If you recall in a previous project, when we were discussing mappings, we were discussing mapping IES and BFO together to identify candidate mappings to align these structures. Where have such a mapping, it need not itself be a well-formed ontology even to reflect a common ground between these ontologies. Now, a lot of what I'm going to talk about here, just so you know, is in the context of that IES BFO conversation, but it is more general. The things I say here can be generally applied to the other mapping targets that we had. So the CCO with respect to time or QUDT. In either case, in all cases, to be useful in applications, mapping should be rigorous. What am I talking about when I'm talking about a mapping with a little more specificity? It's a statement, right? You got a subject representing a class or object property, an object representing a class or object property, respective ontologies, and then a relationship between them. There's that P, that predicate relating S and O, the thing from one ontology to another. This is important. Here are some mapping predicates that you will see if you're restricting yourself to discussions in OWL. And so we're often using OWL when we're modeling ontologies. Web ontology language, OWL2 with the direct semantics. Here are some mapping predicates. So you have OWL equivalent class, connect one ontology to another, one class to another, one property to another with OWL equivalent property. This provides necessary and sufficient conditions for something to be an instance in one ontology and the other. On the other hand, if you're looking for something weaker, sufficient conditions, that is, you have subclass of and subproperty of as well. Now, again, I said I was going to discuss this within the context of BFO and IES. I'm going to go in a little more detail. So this is just from the Protege editor, some of the meta statistics, meta information that you see if you were to upload BFO, you see it's got a little over two over 600 axioms, some logical axioms, annotation properties, subclass relationships, disjointness. You see here, I've got some examples like generically dependent continuant is a subclass of continuant. It's also disjoint with independent continuant and specifically dependent continuant, right? It also has axioms like associated with this class. So like in particular, continuant part of only continuants. So generically dependent continuants, any instance of that has as continuant parts only continuants. And that's what that axiom says. Doesn't say it has any, just says if it has any, they're continuants. We have also axioms associated with object properties. So it has a current part. It has domain and range occurrent. And it is also the inverse of a current part of. And it is transitive, which is to say if X is a current part of Y and Y is a current part of Z, then X is a current part of Z. And again, there are more, obviously, the subproperty relationships, inverses, there's 17. Some are functional, some are transitive. They have domain and ranges. You can see all that. I'm just giving you some samples here. So axiom patterns in BFO that you'll see. So subclass of enforces a mono hierarchy. So every class has one parent. Disjointness is enforced between most sibling classes. There are no existential restrictions. So there are no cases where there's a class in BFO related to an object property to some instance. They're all only restrictions. In every case, there's a class that's restricted to only instances of another class. So for example, process a current part of only process. And similarly for that generically dependent only continuant part, or continuant parts only continuant. Several contain disjunctive ranges. So if you have an object property, there are in some cases rather complicated ranges. We have an object property that can only relate to things of this class or that class, or at least in quite a few cases, things that are not of this other class. And that one's almost always spatial region. In any event, nearly all object properties have domain and ranges, inverses, and a handful have characteristics. That is to say, they're functional, transitive, and so on. If you're trying to look at this diagrammatically, maybe you're more of a visual learner. Subclass relationships, nodes to nodes, subproperty, nodes to nodes. They're two nodes isolated, disjointness, domain and ranges. That R is a relation, domain, range related to classes. And you have over here in the center a class that's related to a subclass relationship. That AC is anonymous class. This is kind of how a node is inserted on which things hang. Subclass of some property with a restriction, all values from some other class. So when you're looking at process has a current part of only process, like instances of process, this is an abstract way of looking at that. C1 would be process. The OWL property there, R, would be a current part of, and then C2 would be process. On the far here, on the farther side, you'll see this is getting into that disjoint range stuff I was talking about. So you have like a class, it's related, then an anonymous class that's hanging out that is the union of two classes that exist. And then itself, in that union, there's an anonymous class, that thing in the middle, or something that's pointed to an anonymous class that is the intersection of another anonymous class and not something else. So this is where you get not spatial region stuff. So you'll see in the object properties for BFO, a lot of them will say, hey, the range here is something of this sort, or this sort, or this sort, but not spatial region. This is the logic behind it. You like embed unions with anonymous classes and take the complement of some of them, or at least one of them. All right, contrast this with the information exchange standard, which our folks in the UK and in Australia are using, our friends over there. We're trying to like align some of the work together in this special summit meeting that we had in some previous meetings. So it's much bigger, you'll see, than BFO. It's got like over almost 4,000 axioms. Right there, they got over 1,000 logical axioms. Now, a lot of these are just classes. As you'll see, they have subclasses, lots of subclasses, like standard measure is the parent class of length, and length is subclass of standard measure. They have lots of object properties, more than we do for sure. And they have sub properties and inverses in some cases. No, not this. No, they don't have any inverses. They do have domains and ranges though, but no, they don't have any characteristics and no transitivity, no symmetry or anything like that. And they don't have any restrictions. So like no only from this class, no some from this class. They don't have any scenarios in which you take an instance and they say, look, this thing, for example, is only part of something like that. So none of that. It's essentially subclassing all the way down, or subproperty all the way down. This is what I'm pointing there. So they just use subclass up. They do allow for poly hierarchies. So there are a couple of cases where they have a class that has multiple parents, at most three. I didn't see any more than that, but in several cases, at least two parents. And just as an aside here, we allow in our circles, or there's a way I should say to respect the monohierarchy principle if you're introducing a defined class. So you can just like introduce a defined class and then have like a way to, if you when you run the reasoner, have that class populate or have classes populate under that, for example, in a way that looks like it's violating monohierarchy. So that's always on the table. So when I say here that they allow for poly hierarchies, I mean they allow for multiple direct assertions of parents, and none of them are defined. So no defined classes. All right, so they also, same with subproperty of, they allow for poly hierarchies here. Although they do have domain and range restrictions, which again, very powerful. Domain and range restrictions are very useful, logically speaking. It's good to have them. You can infer information from them. Although I will say they're mostly useful if you are also asserting disjointness. Because as far as the reasoner is concerned, like you can have all the domain and ranges you want, right? But if they're not disjoint, it could be the same thing. So here are some of the axiom patterns that you'll see. I mean, here's graphical representation of them. Pretty slim in terms of like subclassing, subproperty, domain and ranges, what we saw too. And then on the bottom here, you'll see this kind of poly hierarchy reflected. I'll note these are the common patterns between BFO and IES. So if you're just looking at the classes, just looking at the object properties and the logic around them, this is basically the only commonality. Okay, so I'm putting it that there has to be more axiomatization added to IES before mapping can really be constructed. I suspect you might know why. You might understand why, having gone through the previous project. On the one hand, any IES entity exhibiting only subclass structure would, as far as the reasoner is concerned, be semantically equivalent to some subclass structure of any BFO entity, some portion of it, some part of it. On the other hand, because BFO exhibits richer axiomatization, very little in BFO would be semantically equivalent to anything in IES. Now, there's some caveats here, which I'll talk about like the differences between the structures in general from like a kind of high constraint level. I'll talk about that in a minute. But even here, just looking at if you put your robot glasses on for a second, think about it as like a machine walking through the files. Like where's the logic, right? You're going to get slim connections between them. More axiomatization. So again, these are general remarks. I'm illustrating an OWL. This would apply for a richer language than OWL as well. I say this because BFO has like the cliff axiomatization. IS doesn't have that, although the remarks here could be applied for a richer axiomatization of IS as well. I'm going to give you an example of what it could look like to just kind of programmatically enrich the semantics for IES. So I pulled this. This is from the textual definition for bank in IES. It's an organization that holds a banking license and can conduct financial transactions on behalf of customers. And I will say, both BFO and IES, they have textual definitions. And IES has a lot of rich like logic built into their textual definitions. So like it's not like they just have classes hanging out. There's certainly annotations here that have a reasonable structure, which I'll talk about in a minute. But before I get there, programmatically, what would it look like just walking through this? So you have a subclass of organization. I'm putting in green what's already there, just so you know, in IES. We'll move on. Holds a banking license. Incidentally, what I'm about to say is not like standard IES. I'm not an IES developer. This could be wrong. You know, I said that. I'll say it again. This is up to them to decide if it makes sense or if something else makes sense. But you could add in subclass of holds license, some banking license. Could assert this, and then you might add for can conduct, authorized to conduct some financial transactions that are authorized by some customer, where customer is a class that already exists in IES. So you could kind of walk through, add this programmatically, assuming that, you know, and partly because the textual definitions are in pretty good shape, right? They're like in A and a B that C's form. Now, this is the sort of structure you might get, like abstractly, for a bank being an organization that holds a license, some banking license, and authorized to conduct some financial transaction and authorized by some customer. Note those parentheses there, or you should read them as one variable, like one thing that's being pointed to by conduct some, which is why that customer is pointing to, off through authorized by the financial transaction, as is bank through authorized to conduct. Both pointing the same node. So, but who has this kind of time? Do you know how long it took me to do that? Like 2 seconds, but like seriously, who wants to do that, right? Like you don't want to do that if we can help it. So some ways forward were gestured at in previous work, right? Like we took ourselves a task creating some mappings, exploring IES and BFO, the comparison as well as CCO and time and QUDT. We're trying to enrich the semantics of these structures, and we kind of had a little bit of a pipeline to work through. Some of you are picking up that, and no doubt in the second option for the final presentation. But we've seen some of this before, right? Strategy being leverage tools, or strategy expanded, I'll say, to leverage tools to help uncover grammatical patterns in IES textual definition. So no doubt you noticed when you were spelunking in IES, there weren't a lot of axioms to pull from, right? So you've seen this. The scripts were targeting axioms, and your job was to provide new ones so that you could generate some kind of candidate mappings between them. Now we were largely doing that manually. Like there's scripts running that were kind of, you can feed these things in. But who has that kind of time? No doubt some of you probably did what I just did with the bank, like added axioms from textual definitions. I'm sure some folks did, just to get something into the IES file or an extension of it so that the scripts could run and they could check out axioms between these two structures. I'm saying here we should leverage tools to uncover grammatical patterns in IES, the textual definitions, and use those patterns to suggest our axioms for addition to IES and construct mappings based on some of those, or at least candidate mappings between the structures with some of these toolings. The idea being textual definitions to IES enrichment to IES BFO mappings. Now, here's something of what a pipeline would look like. Extract all RDFS comment definitions from IES. So definitions in the IES file are appended with RDFS comment. So you'd want to look for that, right? Parsing, identify subjects, genus, terms, clauses, verbs, some kind of patterns to the common textual definition structures, and then construct templates for our axioms for subclasses, existential restrictions, universals, any kind of roles or characteristics reflecting the parse definition parts, and then add those axioms to the IES test file and then review. Here are some textual patterns. So much like I saw the axiom patterns in IES, we can point to some textual patterns that might inform this kind of approach. So they use count nouns just like we do. So instead of saying, just water, which is not a count noun, they say things like, they don't say exactly portion of water, but they say things like table, where you count, not mass terms, count nouns, and most of them are singular. Almost always they're singular, which is good. This is what we do too. Singular we use because we don't want to confuse people when they're looking at a class and make them think that the classes is the instances or the instances of the classes. More interesting for us, I think, is that most of the definitions follow the A is a B that C's pattern. in IES, which is great. Some of them follow the sum AB of C, and you'll see some of this in just a second. There is, of course, the multiple inheritance that I was pointing to, that polyhierarchy stuff that is represented in the textual definitions. But in any event, some things that I noticed, right? This is kind of a general structure that you see in about 400 of the textual definitions from IES. Some noun, that, which, where, something else. So for example, an agreement stage is an event which is part of an end-to-end agreement. You have about 400 textual definitions that take this form. And I have a suggestion. So now I'm moving from the parsing into the enrichment stage, right? Like, here's a potential way to enrich it. You have a class, subclass of something, some other class, and related to something else. What this look like here? Agreement stage, subclass of event, and it's part of some end-to-end agreement, right? Hopefully you can just see it straightforward. You can see like you've got like these 400, roughly speaking, textual definitions that I think could be enriched, hopefully by content that's already there, just in this kind of patterned way. Now, I will say this won't work for all of them because not all of the classes that are referenced in these textual definitions, like not all of the nouns, that is, pick out classes that are there. Although I will say they've done a pretty good job of capitalizing the ones that are. So just like CCO capitalizes their classes that are in the ontology, IES seems to be doing the same, which is a pattern that could be useful when you're trying to generate enrichment of this sort. New, that's the new part. Also, about 50 textual definitions are of this form, a noun of a noun. So amount of money is a specified amount of currency. I think, without stretching too much, they fit in this pattern, or similar pattern as well. So subclass of a class and related to some filler. So amount of money is an asset. Note that here I'm adding the genus. So when I'm pointing to this pattern, I'm saying it can be enriched, but I'm noting that this pattern that you'll see in these textual definitions doesn't reference the genus. So I've added the genus in. So amount of money is a specified, is a specific amount of given currency. This is not in the A as a B that C form because the B is not there. But you can look in the file and see that it's a subclass of asset, right? So this is why it's not exactly the previous pattern. In addition, you'll have patterns that look like this, 25 textual definitions, roughly speaking, a temporal state of. And now I'm getting into the semantics, right? A little more of the semantics that are embedded in textual definitions. And so again, same kind of format, except I've embedded now a little more specificity. An account state is a temporal state of an account. So you'll have the C subclass of temporal state and state of some filler. You plug all that in, this is the new part. So hopefully you're seeing that I mean, there are patterns to the textual definitions, and then there are kind of patterns to the enrichment, or at least some minimal enrichment that can just be hard-coded in, or just coded into some scripts, right? Put this in there, then generate a new file that you can review, or someone else can review. To make this successful, people who are like ready to review this will need to match IES textual patterns to canonical OWL forms in the way that I was just doing, and then review those OWL axioms for consistency, clarity, coherence, etc. And this could be output, ideally, into what we might belovedly call an IES BFO mapping generator that takes the textual, once those textual definitions are converted, this generator would compare BFO and IES axioms, and then mapping would become a problem in some sense of structural correspondence between subclass property and equivalence axioms, existential universal restrictions, domain and range restrictions or relationships. The idea being here in just BFO and enriched IES, extract normal axiom forms like domain and ranges, existential restrictions, etc., and then map the enriched IES and BFO signatures together, and then use reasoners to check out if they're consistent, coherent, and honestly, if they get the appropriate entailments that you expect. So there should be test cases in there as well. What does this look like in a little more detail? Not too much, because it's kind of thinking it through. For each class in IES and BFO, a system will extract some normal form like a genus, set of universal restrictions, disjointness assertions, stuff like that. And then the classes or object properties can now be compared using what I'm what I'm referring to as an axiom fingerprint. Now, what is that? It's an axiom fingerprint for a class or object property is just a collection of their normal forms, the normal forms of the axioms associated. So this will, in most cases, I'll add, for these fingerprints for IES, in most cases, these will not align with the axiom fingerprints of BFO elements, classes, or object properties. This is for a couple of reasons. One, like, and you could like put yourself into this headspace. Just think, imagine IES fully enriched with all the axioms that it needs. Like you absolutely got the full semantic theory on the table. It's at least as rich in its axiomatization of as BFO is. Imagine those. You got IES plus. You're still not going to get a match between them. That's because of kind of the general modeling constraints between the two differ considerably. So IES is a four-dimensional representation. They put everything on the kind of spatiotemporal side, whereas BFO has both the four-dimensional, i.e. the spatiotemporal side, and the three-dimensional, where you've got things moving through space and time. Right, so you've got both the 3D and 4D. You just on the one hand and then the 4D on the other. And so when you're moving from IES into BFO, there's going to be an expansion in some sense, expansion of the representation into a bigger space or to different edges and nodes, a different collection of edges and nodes. And then if you're going from BFO into IES, there's going to be a contraction. At least this is how it's presented. Now, having said that, I am not so convinced that that is actually going to have us result in completely different axiom fingerprints. Because in a lot of the exercises that we've been conducting while looking at these different structures, to my mind, if I'm just thinking about the edges and nodes, they're just differently labeled edges and nodes. I'm not so clear that there is actually a numerical difference. So putting this another way, if IES wants to represent the kind of rich domain structure that we represent in BFO, they're going to have, I think, at least as many edges and nodes as we do. They're just going to be placed in a different, they're just going to be organized in a different way. So if they want to model this computer moving through space and time, they're going to use different relations than we would, but they're going to use a lot of relations as well, just like we will, because they want to track provenance. They want to track where it is at a given time. They want to track how it participates or relates to other things going on. So saying it's all in space and time, that's fine metaphysically. Saying 3D versus 4D on the other, that's fine metaphysically. But if you're just thinking about it from the edges and nodes, from the logic, it's not obvious that they're different. It's not obvious that the logic, the actual edges and nodes are going to be so different. So there is what I'm saying here, you should take, like on the slide, it's potentially true. There may be no match directly with the axiom fingerprints. But if you're thinking of the axiom fingerprints as I am, as just the logical constraints, just the edges and the nodes, just those relationships, it's not obvious there won't be a relation, connections between them, even though it looks like in one case, when you move from IES to BFO, you have to expand in a sense, and then from BFO to IES, you have to contract. Yeah,
probably we would know if we knew really how the object properties of IES work.
That's right. That's exactly right. And I think we're going to get there, right? That's right. I think we're going to get there. Like today on the call, we were discussing this. We're like, yes, IES does need to have richer axiomization, both textual and for the OWL. And I think as we get closer, it will be clear. But my suspicion is, in fact, the world is as complicated as it is, right? We're going to have the same, roughly speaking, the same number of edges and nodes because they want to represent stuff richly too, just like we do. So
let's say we understood completely IES and we discovered that there is a expansion from IES to BFO 1 to 5.
Yep.
Some people say. But then if you haven't studied the object properties of IES, how can you necessarily go from this is the expansion or contraction to hey, it happens the same way for object properties, maybe not.
Sure. That's right.
That's your
You can. We have to get in there, right? We have to check it out. And it may be the case, just for contrast, it may be the case that like if we want to represent, you know, entity A or for class A, some instance of class A over an IES, then anytime we have an instance of that class, if we want to map it over to BFO, we have to like bring in a bunch of other classes. We have to have like it's some 3D thing related to spatiotemporal region that extends off space and time and all that good stuff. We have to add in a bunch of relationships there. It may be the case that that is true. Now, even in that case, I'm not worried about approaching the project in this way. So again, just to be clear, I'm saying there is a case where we genuinely do need to expand, we genuinely do need to contract, and so there's going to be a mismatch. I'm not actually concerned that this is, or worried that this is a bad approach, because all we need to make this mapping work is to tell me what the transformation rules are when I go from one space to the other. And so if it is the case, anytime you have an instance of this class, you add 5 new things when you go to BFO, well, I know what I have to do. I know what I have to do. And so I can look for those things. And my expansion becomes, or it's something that I can like code into an extension of BFO that's representing IES space. Similarly, if I go to the other, I have to drop down from 5 to 1, going into IES. It's an extension from IES space that in which I can drop the BFO representation. And to me, that is a one-to-one mapping. That is one-to-one. So there was some pushback. People are like, they're not going to be one-to-one. I absolutely think they're going to be one-to-one. We just got to actually think about extending the theories in the appropriate ways so you can lasso the right interpretation with respect to each of these ontologies. Just give you a little diagrammatic representation. This is from a paper that they worked on, as well as Ellen and Giacomo and the IES folks. They did most of the heavy lifting, no question. What you see here is IES on the left, or my left, and then BFO on my right. We have, I forget exactly what the case is, something about representing an organization of raters. They're like subject of interest of investigation. And so you have, you know, an instance here on the IES side, instance of an organization with a name. And then you have somebody's inquiring about or they're inquiring about this organization, as well as another, it's Badger organization. I'm sorry, under this Badger investigation. And then similarly on the BFO side, we leveraged a bit of CCO for this. You'll see organization as well. You have Operation Badger Plan. Essentially, this is investigation as well, and a planned act. Right. And then this Operation Badger Plan is like prescribing what goes on in that investigation. And there's a document associated with it that bears some information, et cetera. And so it's a different structure for sure. Not that different. Not that different. But in any event, there's like you can see the relationships between these. And if you're thinking of this kind of in terms of edges and nodes, hopefully you can see that there are like recipes that you could write when you're moving from one structure to another. So you can lasso around the appropriate content from, say, IES to BFO and BFO to IES in a way that doesn't allow you to have to go in and do it manually as you willing participant grad students did so much on your own. Yeah. All right, so for each pair of classes, this is my suspicion. What we do is we compare these axiom fingerprints for alignment, overlapping restrictions, similar properties, disjointness, similar state of or role of structures. And then we'd combine those with transformation rules of the sort that I was pointing to that determine if some kind of expansion or contraction is needed, and then what axioms would need to be added to a target when we're doing the mapping. Now, it is my belief that a rigorous characterization of IES will provide a foundation on which every element can be mapped to some combination of elements in BFO and vice versa. You know, on the one hand, because we're scientists, we shouldn't assume there will be a one-to-one of named elements. That is to say, things that already have names in BFO, things that already have names in IES. We will likely need to extend each theory and project into respective extensions. So this, what we'll be mapping from IES into BFO into, or that structure will be BFO plus. Similarly, when we're going from BFO to IES, we should expect to be mapping into IES plus, an extension of IES. Transformation rules will tell us what to ignore or add as we move between these axiom fingerprints. Summary, textual definitions in IES contain rich semantics but lack OWL axioms. We can extract grammatical patterns and generate canonical OWL descriptions. And then these enriched classes now carry an axiom fingerprint that we can use as fodder for comparison to the BFO structure. And then we can construct, I have hand-wavedly constructed a mapping generator here that compares the axiom fingerprints to find structurally corresponding BFO classes under certain transform rules. Again, hand-wavy. Nonetheless, this is the idea. All right, let me pause there before I get into debugging. Any questions, comments, concerns? Yep.
Yeah, I have, John.
Yes.
A question on the slide with the diagrams of IES and BFO. Yeah, this one. So the right side does not contain any reference to IES anymore, no?
The right-hand side? Yeah. So these are actually like just representations of the same use case in the respective ontologies. So there's no relationship here, even in the paper, right? We weren't even putatively at that level. So we're just kind of showing how we can model the same case. That's right.
But that's not the target. No, the target is to say somehow that an organization is more or less equivalent to a CCO organization. That's the target, no?
Yeah, in some way, how do you do the translation? How do you get a transform from one to the other in a way that allows you to leverage machines? Because I'll tell you what happens now, and this is what people ask for. They say, okay, I want to use IES, but I'm using BFO. How do I do it? Can you give me a design pattern? And they ask for something like this. And what they do is they go back and they model everything manually again. Now, I think that's a bad idea. It introduces a lot of opportunities for error, introduces a lot of additional work. They're not confident. They're not going to be competent on most of the time to get it exactly right. And sometimes like the ambiguity built into these diagrams, they're not going to get it right at all. Right? They're going to get confused, right? And understandably confused. And this might only come out later. These are not precise enough, and they're not precise enough for use in machines. They're not precise enough to avoid ambiguity and logical missteps that are certain to arise. And so first steps for sure, but not really anywhere near what we need. Yeah, Betty?
Yeah, these are the graphs that you see are not even completely in the sense that we use shortcuts. So
yeah.
You mentioned organization and you see organization CCO in the BFO side, but actually, as we mentioned before, of course, maybe the theory is not, we haven't covered it completely, but since IES says basically processes, material objects, material entities, space and time, or comprising one entity that is called a substantivalist entity, you would have many entities on the other side for on BFO to represent the same portion of reality, okay? Now you see organization on one side and organization on the other. We said in the text, like we're not going to repeat this pattern all the time, but you would electronically. Like you have to write like five entities for every basically diamond that you see there.
Yep.
So it's even a shortcut that we use. It's even bigger, way bigger.
Yeah. So basically, like upshot, even here, like, and this is just pointing to that ambiguity, right? Like even a comparison, something that is small enough for a human to grok, right? It's almost necessarily going to have not everything in it. And what we want is something precise enough we can feed the machine to take that burden off of them so we don't have to worry about what they're going to miss and worry about the ambiguity and the misinterpretations. And we're not here yet with this. This is first stab. Wanted to get something out into the community to show them that IES BFO crew were working together and trying to get something going here. And after that, after this was published, we started shifting over into, okay, now how do we do this for real? And what I was just presenting was one aspect of an overall mapping strategy and effort that's going on. The other is focused on those identifying those transformation rules I was gesturing at. And but after Friday's meeting, now we're going to bring our houses together and we're going to start doing this work together. But yeah, and answer your question, yes. That's right. Long way to say yes.
It seems that there is so many options to do this from a pragmatic point of view. Like just saying one option, I could say, okay, I'm interested in mapping from IAS to BFO. I'm going to say that organization is sort of equal to CCO organization. You know what I do? I create an IES version where I strip everything from organization because I get all the semantics from CCO. I mean, that seems like a clean solution because you can just generate a mapping that is sort of workable, transparent. Because if you equivalent them with all the actions left and right, you get one big mess reasoning wise from my perspective.
This is true. This is true. So some of the uses of like actual mappings that I've seen have to do with a need to, genuinely represent almost competing logical structures, where one of those structures has been hard coded into a code base for better or worse, right? Sometimes you just need to hard code an IRI, right? And sometimes you do that and it's hard to find like all the nuance in places that it kind of can permeate. But nevertheless, you might be requesting, this is not uncommon. I need to be able to represent like the actual difference in semantics between these things. And in those cases, having a mapping that shows you where they like organization in the IES space differs and is similar to as precisely as you can the organization and CCO space from a reasoning perspective becomes valuable. And again, if you have data that's already like represented by IES and you want to see what it looks like, as it were, reasoning wise or just visually in CCO, and be sure that it is the appropriate representation within the scope of CCO, it's probably not going to be the case. You can just tag up the IES organization and the CCO organization because I suspect they have differing semantics in some respects. But you can extend down maybe from the parent class or sibling class of organization, or perhaps just from the organization class in CCO itself, something that is tracking the semantics of the IES organization. And then you can say, okay, this is where they differ. This is where they're similar. They have this much semantics in common. They don't have this. Maybe they're not disjoint, right? They don't have disjoint anything. They're not disjoint from any other siblings or something like that.
One last question then.
Yes, sir. Yes, sir.
Say I would have organization, I want to map it to CCO. CCO organization does not exist. Can I just say then, okay, I'm going to create an organization, to the best of my knowledge, and then map it that way with an equivalent.
Yeah. And I think this happens, right? So let's run that case through. So you have an IES organization, and you know from the semantics that it has these sorts of restrictions, and from like the textual definition, for example, you can surmise that it has material parts. It's the sort of thing that has material parts, right? That might be all you know, that you can actually represent in CCO. At least you know that's a material thing, right? At least you can infer that information so you can create a subclass in CCO for that. But it's all the name of the game that is all about like mining the IES structure and definitions to the extent you can, so you can find where to latch the semantics on that will take you into the CCO space as low down in the hierarchy as you can. It may be the case you just need to, and sometimes this happens, it may be the case you just need to extend things from like entity, right? It may happen. I haven't found a case that happened yet, but it may be the case that just happens. But at least there's something in common, right?
Okay.
Hey, John, I had a pretty simple question earlier. You just mentioned anonymous classes. I just wanted to know if anonymous classes are equal to blank nodes, or are they different?
The blank nodes, anonymous classes, blank nodes, I'm going to use those for this purpose interchangeably, right? They're the things
Okay.
that they're like hanging on, like they don't have names. So they typically aren't given like RDFS labels or anything like that. They are given identifiers, but those identifiers change across serialization. So they're like only local. So it's where like classes, object properties that have IRIs, like unique like identifiers across the web, right? And the anonymous ones, they're only local. So if you like go from turtle to RDF-XML, your anonymous names or your anonymous identifiers likely to change.
Okay, got it.
Super important if you have a workflow that like relies on exact identifier. This came up not about 2 years ago when somebody was describing their workflow at a BFO summit meeting. And they were like, "Can we do this with the IRIs?" And I was like, "What about the anonymous ones?" And they're like, "What are you talking about?" And I'm like, "You say you're reserializing." And they're like, "Oh God, oh God, you're right." I'm like, yeah, maybe fix that. Because you'll get different identifiers and you'll start your code. If you're like have code that's ingesting, looking for specific IRI or specific identifiers, it's going to miss those. And that was in fact what was happening. They thought they were running reasoners in a way that missed a bunch of anonymous classes after they reserialized. Don't do that. Look out.
Can I have one more question, John?
Absolutely,
Just,
absolutely.
a thick one. Just
Go for it, man.
let's say I see IES organization. I sort of synchronize the definition and the axiom, so there is no difference there. Just saying like, okay, we're just going to reason from the same set, whether axioms or definitions, textual is going to be the same. I come to the conclusion. Listen, it's a little bit less than a CCO organization. It sounds like it, but it doesn't walk like a duck.
Yeah.
Is it then sort of an option to say, okay, CCO organization is hanging under something?
Uh-huh.
I am then somehow going to say, I'm going to transport some, I'm going to take away some stuff from organization because from the CCO organization, because the IES organization is just less.
Uh-huh.
It just says I am less than a CCO.
Yeah.
Semantics are very seductive, but it just says it's less.
So you could be asking two things, right? So let me see what you're asking. So it could be the case that we're doing this kind of analysis and you're like, you know what? The CCO organization, the semantics around those were too strong. They're stronger than I intended. And I am now seeing that by looking at this other structure, and I think they're actually correct. And so what I'm going to do is strip off some of the axioms from CCO organization to align better to what I'm now convinced is the appropriate way to model. That's fine. Yeah, absolutely. Like that happens all the time. One of the benefits of mapping, I find, is that it forces you in a sense to preach to the Gentiles in their own tongue. So, and it does in fact happen not infrequently that one group will say be mapping into BFO and then realize, oh, we were doing this. We had too rich of an environment around this, and we weren't thinking about counterexamples that you guys aren't susceptible to. And in fact, we gotten ourselves into tizzies over how to handle these, and we were going to make some crazy choices. But in fact, all we really needed to do was maybe drop one of our restrictions. So that's totally fine. That's reasonable. In fact, that's desirable. That's just good kind of development, I think. You could also have been suggesting that we look at CCO and we say, okay, there's got these additional constraints, and IES doesn't have these constraints. And I am motivated to line these up as tightly as possible for the purposes of my mapping. And so what I'm going to do is I'm going to drop some axioms from the CCO IES so that I have this one-to-one that I'm looking for. I would be less inclined to that just on like for the mapping purposes. What I would be more inclined to do is create a sibling or perhaps a parent that has the appropriate mapping so that I'd have an anchor that I could lock into for the CCO. It'd be an extension file of the CCO, right? And there would be some relationship to either, again, the siblings or parents of organization, presumably, but it would basically be kind of a dummy class for the projection. And I would give it something like IES organization map. I'd name it very clearly. Right?
Yeah.
That's not only desirable, that is overwhelmingly likely to happen.
Yeah, got it.
Yeah.
Got it. So CCO remains the same. You get sort of an overlay file. That overlay file sort of imports from IES.
Yes.
and it sort of creates an IES or an organization light or whatever semantics we seem appropriate.
Yes.
And that's a little BFO construct with some CCO stuff around it, and then we say, bam, that's equivalent to my IES.
That's right.
And that mapping file in between, sort of completely sort of leaves the integrity of IES in place, but that mapping file is probably going to look from the perspective of, hey, the IES definitions and the IES axioms, we are going to sort of entertain the full set. Maybe they don't say it.
That's right.
But we are going to think about the full set, and from there we're going to work.
Absolutely. So I'm like overlay files exactly how to think about this. That's exactly how I'm thinking about this when I'm thinking of mappings. It's like an overlay for sure. And two, I just wanted you're raising something I forgot to mention, but I'm glad you did. Okay, so hold on, I'm almost gonna sneeze. Don't do it. Okay. So let's say we're thinking about this example, right, where you're projecting into some space in CCO from IES. You're taking that IES organization, projecting it, whether it's sibling or parent, something like that, of organization in CCO. Now, look, I think that is probably the place to start anyway. Like assuming that you'll be projecting into some dummy classes or not, like some kind of like placeholder classes anyway, because I want to run reasoners over the resultant structure with the overlay to learn when two classes are the same. So I want to axiomatize as richly as I can each, have the appropriate transformation rules to inject into spaces. And then I want to check that I can prove the right entailments follow that I would expect to see from the space so that I can determine whether like what I projected into is something that already exists in CCO or if it's genuinely new. And so I don't want to prejudge by saying, oh, I know what IES organization means in BF or CCO organization. That's something I want to learn from a rich axiomatization of each in their own respective languages with a way to transform and get that one signature in the other to determine provable equivalence. That's really the goal. That's the central conceit as I see it.
Yeah. It really sounds like it's a lot of work. There's a lot of possibilities, and progress is progress. Let's put it that way.
Absolutely. And my goal, I mean, I really want to, I don't want to do this by hand, obviously. Absolutely not. And so the research project is identifying a way to automate all of this. And I think ultimately it's going to depend, like there's going to have to be humans in a loop. It's going to require us to raise the bar on how we like approach construction of textual definitions as well as the OWL axioms. I think that's what we have to do anyway. And so, I'm in for a penny and a pound.
Yeah. So just from a tooling perspective, doing a two-way translation and then a checker on it seems to be one of those things that is probably required. Like, hey, this is a reasonable translation from axiom to text, from text to axiom, and it sort of gives you a rating like meh or no.
Yeah, right.
No?
That's right. That's exactly right. We got to have some way to filter for sure.
Yeah.
There's too much otherwise.
Yeah.
Very good.
Thanks.
Yes, sir. Thank you. All right, where was I? So, all right, I'm gonna hop over here. Okay, so I'm gonna talk now about debugging. I'm gonna talk about this because I've noticed. So I've noticed that in talking with some folks, I keep finding myself, passing over debugging skills that I picked up over the years, and I wanted to make them as explicit as possible. So this is like a teach a man to fish kind of situation. So I want this to be on your radar when you're thinking about debugging, because debugging has been a central thing you've been engaged in throughout the projects here, no doubt. You've heard the term, you've done it, whether you knew it or not. You've probably done it unintentionally. I'm sure some of you have done it intentionally and know what you're doing, but it's worth repeating. So I'm going to talk through some principles, some guidance, not from me, from Stanford about this. But look, what this is, you're finding the root cause or workaround or possible fix for some bugs. You're playing with code, you get an error. I know some of you never get errors. I know some of you lucky souls have never seen an error before. But you want to figure out what's going on. Like there's an element of critical thinking involved with this. There's an element of no doubt an element of critical thinking involved with playing with code. There's also an element of grit. You're essentially like, you got to figure out what went wrong. I'll say the problem that people face debugging is not really that much a technical issue as it is psychological, I find. There's no real code book for it. But there's some principles, some guidance that might help you, some like rules of thumb. Again, not from me, from Stanford. These 11 truths of debugging that I found valuable early on. So, all right, you're running some code. You think it's great. You spent all day working on this code. I don't know if you've ever done this, but I wrote code once, like a pretty sizable amount of code, and I ran it, and it ran the first time perfectly, like no bugs, and it did exactly what I wanted. It happened one time in my life, and I've never been that happy ever. I got married, had a child. I've never been that happy as I was in that moment. And I was like, I'm gonna take a vacation. It is almost always the case that something goes wrong. So uh, intuitions and hunches about what went wrong or great, you got to test them. You got to check intuitions and hunches about how the workflow goes, how your code is written, how things plan out, how consequences of your code. Those are great, but you always got to test, right? So you should always be thinking when you're writing code or putting projects together, how would I test this? How would I test if something right at this step went wrong? You can put like print statements in to help guide. You can put like little tests. You can embed them. And later we'll talk about using LLMs to help you identify where you can put in things to test as you go. But look, testing. It will save you so much work in the long run. Also, as a rule of thumb, look for the simple stuff first. It's easy to be like, I've spent so much time on this. And there's some bug here. I bet it's a really complicated logical bug that's embedded in the code. You probably missed a period. You probably put an extra space somewhere. You probably have, I don't know, just off the top of my head, you probably have ontology-tradecraft / ontology-tradecraft / in your path for a file, and you're getting an error that says, I don't know where this file is, right?
Okay.
Yeah, some of you feel triggered. Right? I'm sorry. It wasn't just you.
No, it's okay. It's a good example.
It wasn't just you though. So even the simplest omission can lead to super weird behavior. So like you're probably reading that error and you're thinking this file, I'm looking at this file right here. Remember the path, like it's being picked out by the whole path. So look for syntax first, and look for simple explanations for what's going on. Maybe you don't have a package. Maybe you've got some conflicting dependencies or something like. All right. So the clue to what is wrong in your code is in the values of your variables and the flow of the control over them. So if you've got something legit wrong in the code you're writing, walk through what's going on in your variables. Or start printing things out as they're instantiated, right? Like see what's happening every step of the way. You can watch the flow of your code. If you can get it to run, right? It just might be a big if. Like you can see as the variables are updated, what's going on, and you can see if that's what you expect. You can even plug in like toy information, what you would expect. So you know exactly what to expect. Say, why didn't I get that? Why didn't I get that? But look for the variables. Don't panic. And if you find yourself panicking, this goes to that psychological aspect. If you find yourself panicking, you're like, I don't know what's wrong. I'm mad. I'm sad. I need a hug. I need a donut. Something like that. Take a minute. Just take a second, walk away, do a breathing exercise, leaves on the stream. Just don't panic. You need to approach this systematically. You need to approach this like carefully and methodically because your code don't care how you feel. It's gonna And if it was working a minute ago, I mean, this incidentally, great, powerful rule of thumb. If your code was working a minute ago, but it doesn't now, what did you do last? This links up with being systematic and persistent. If you're trying to if you're changing things, keep a record of what you're changing. It's really easy to get excited and write. And next thing you know, your code breaks, and then you're like, what did I do wrong? It's hard to see what you did wrong. Yeah, there we go. Sane adding in. Create a branch for every investigation. That is great.
It's
That's
cheap.
very,
It's
very,
cheap. Just
yeah,
create it, fuck it up, roll back.
that's
Create it, fuck it up, roll back. Create it. It works. Merge.
absolutely. I love it. Yeah, this is great. Use let the branching do your versioning for you so you can keep track of it so you don't have to. It's a great advice. This will so help you in spelunking. I mean, good Lord. It's like the phenomena you spend all this time writing a paper, and then like I don't know, you have this experience, you go down a rabbit hole, and then you go all the way down this rabbit hole, and you're just excitedly writing, and you write all this stuff, this beautiful stuff, and then you get to the end and you realize you were wrong. You're like, I have to scrap all of this. I don't know what to salvage. You can adjust, you can alleviate some of that. Ah, yes. Obi said if you're having trouble with debugging or code not running, you can reach out to him. I can help with most of the errors. I love it. It's great to have a community of debuggers. Look forward to that. All right, so if your code was working, but now it doesn't, what was the last thing you changed? And don't change things haphazardly trying to track down or fix a bug. It will just make the behavior more challenging to interpret, and it'll be harder for you to track, and you're going to overwhelm yourself. Be systematic again, like be systematic and persistent. Don't just start throwing stuff at the wall. And if you find some wrong code that does not seem to be related to the bug you were tracking, fix it. You find a syntax error and you're like, hey, this error that I was looking at seems completely unrelated to this. Fix it anyway, because it might be related to it. You shouldn't always trust error messages. They're not always as exact. I mean, it's tough to be exact about error messages, right? So like you shouldn't assume it's got the exact information you need to solve the bug. So if you find an error, fix it. It might be exactly what you're looking for. It might not. I have many, many, many occasions where I found something that was an error as I was looking for another bug, and I fixed it, and nothing happened, right? Except I probably saved myself some time later fixing that bug I was going to have to fix anyway. Of course, on the other hand, I absolutely have encountered an error I thought was completely irrelevant or encountered a bug that was completely irrelevant to the error, fixed it, and like magic, it felt like everything was fine, and I got to go on my lunch break. Now, hey, I love this. I think this is true. You should be able to explain in a Sherlock Holmes style the series of tests and facts and deductions that led you to find a bug. Think about it like this. Walk through carefully. This is what it means to be methodical, precise, systematic. What are the steps that led you to find a bug? You ought to be able to deduce one by one, line by line, step by step. And this is not like a requirement, of course, but if you can do that, you can start rooting out, paths that aren't going to help you. Putting this in contrast, I think this is best understood in contrast to like an attempt to go bug hunting without sort of a methodical approach. It's very easy to try a bunch of things and forget what you tried. Forget or not see that you actually already tried to solve this. In fact, depending on how tired you are, you might end up spending a lot of time trying to do the same thing in a more complicated way. Simplify, simplify, simplify. Try to be careful and deduct. And be critical about your beliefs of your own code. You think it works one way. What is you think it works one way? You think you've got that, you understand the flow of control, you think you understand what's going on. Take kind of a skeptic's view. Sometimes you just need to step outside of yourself and be like, okay, this is broken. Like I've screwed up. What did I do? Now use your intuition about where the bug probably is to direct the order that you check things. Again, intuitions are useful, just test them. They need to be tested. So you might have some insight or instinct about what's going on. Maybe you ran some basic tests. You're like, okay, that's not what I expected over here. Use your intuition to help you order things and also make it easier for you to engage in this in a methodological way. Last here, debugging code is more mentally demanding than writing it. Just like editing and revising a paper is more mentally demanding than drafting it. We all know that. Take a break. If you're going on too long, take a break. This is true. The go do something else for a while, come back and find the bug immediately scenario happens way too often for it to be an accident. It happens a lot. Like take a break, go have a sandwich, sleep on it, wake up, see what happens. Sometimes you just need space and let your, I don't know, the back of your brain work on it until it's fixed. And then you come back with fresh eyes and boom, you see both. You have an intuition of where to hunt. You're ready to engage methodically, systematically. Same too with writing. This should not be unfamiliar, right? Somebody gives you critical feedback on a paper you submitted. Reviewer 2 is coming at you in the comments, and you're like, what? This person's crazy. I'm going to try to address it right now while I'm animated. I've spent a lot of time trying to do this. And then you take a break, you come back, and it's like, that was all garbage. Or worst case, you send it off and they reject it, right? Just take a step back, breathe, do some breathing exercises. Fresh eyes. Truths of debugging. Now, before I move on, we've got some experienced debuggers here. Yeah, every subsequent, Sonny is adding that branch, or number 6, every subsequent investigation needs a fresh branch. 8 is rubber duck debugging. What's that? Let's see. What was 8? Yeah. Explaining all of the facts.
It is literally, it's not my comment, but it's literally placing a rubber duck. You can also talk to your teacup and explain to the teacup what's going on.
That's right. I think of
Sort
it,
of
yeah,
Eli
explaining to my
5.
daughter. Yeah, I definitely think of it like explaining to my daughter. Like sometimes this has happened a couple of times where I got stuck on something and I'm like hanging out with her and she's like, "What are you doing?" And I'm like, "Well, babe, I introduced this function. Let me explain what that means." She's like, "I don't know what you're talking about." Still, it's a very helpful exercise. But let me pause. So I would say we have some experienced developers in class. You guys have any tips you want to add to this? Anything you want to expand on? Yes, sir, Mike.
Elongate your code if you have complex code, right? Because a lot of times you can do things in 1 or 2 lines and it's difficult to debug sometimes.
Yeah. More expressive code so you can see what's going on rather than that like compact style.
Also
Yeah.
helps with things.
That's true. Yeah, you have more options for printing things. Yeah. That's good. That's good advice. I've definitely expanded code just to see what's wrong.
Yeah, I always hated looking at people's code when they were showing how great a programmer they were and did it all in 1 line or something.
Laconic. Yeah. Good. That's good. Yes, sir.
Yeah, there's one. I have IntelliJ, which is sort of a professional code editor. And it's a bit niche, but what it excels at is code refactoring. You can extract methods, you can inline methods, you can change the order of the variables, and every time you read, clean it up. I mean, you did the analysis. Oh, I could maybe better rephrase it this way. Bam, do it. Because then you sort of gradually plow through your whole code base. But don't only read, just anyway, in IntelliJ, it's very easily to say, rearrange it like this, inline this code, extract this code. No, I want the arguments in this order for readability, just right. Gardening. It's gardening. Software is gardening. Keep it clean, cut the branches, rake the leaves.
I love it. That's good. That is good advice. I like that metaphor too. As somebody who really needs to rake the leaves in his yard right now. Yeah. Definitely it's looking rough. Obi, what you got? You're popping off in the chat. You want to jump in here? Can you talk? Maybe you can't talk. I meant popping off in the best way, obviously, like in a good way. Let's see. Obi says use a code editor like VS Code, right? Where your method is doing before you code it. It helps a lot. That is good advice too. Like, what is your method supposed to be doing? Write that out. And VS Code, obviously, like everybody in here better be using VS Code or something like that. Hope he doesn't have a mic. That's unfortunate. I do enjoy your voice, but this will do if we have to. All right. So, debugging 201, LLM edition. Dun dun dun. Here's some advice. So I use LLMs to debug. They're not perfect. Sometimes they spin me in circles. I get angry. And then what do? I take a break. Because I was suggesting you should do that too. All right. But in any event, I've been recommending folks who need some debugging help or having trouble with the projects to go use your favorite LLM, give it a stab, see if it can help you unearth what's going on. Here's something that I've noticed from working with some folks that I just want to call attention to. So tell it the errors. It might seem like common sense, but perhaps it's not as, if it's not, just give it the errors. Like you can copy the error and put it in and be like, what's going on? You can also tell it what code was used to generate it. You can tell it about your environment. You can tell it what commands were used. You can just copy and paste this stuff in. It's not infrequent that I'm just like, hey, I got an error. What happened? And then usually I'll just drop in the error and be like, what happened? And then it's like, this. And then I'm looking and I'm reading its description and I'm like, oh, you probably need more information. Here's the environment setup I have. And then it's like, oh, that was useful information. You're the best person in the world. I love you. Here's what's going on. I'm like, oh, you need some, let me give you some snippet about the code, or here's the whole code. And it's like, oh, you're the greatest person ever again. Thank you so much. And here's what's actually wrong. Like, it's basically like, so just feed that in and use that like as a good rule of thumb, because half the time it can tell you what's going on with the error. I mean, it's not 100% perfect, but it's good. It's good to help prompt you about like what potentially has gone wrong. You can also, when I do this, you can use the LLM or an LLM to generate multiple possible causes. Now, a lot of them will do this on their own, right? Like, and also multiple potential solutions. I think that might be more common, but you can just prompt it to provide multiple possible causes for the problem. And importantly, minimal fixes, because those things get verbose. I don't know if you've noticed this, but it'll have you doing some crazy stuff if you let it. And I have noticed from some folks who've reached out to me, like, I don't know what's going on. I'm using an LLM. And it's got me doing all this. I had to like drive to Albuquerque and pick up a USB. And I'm like, no, tell it, prompt it. Oh, initially, minimal fix. What would a minimal fix look like here? Now, you might not be able to do the minimal fix for various reasons, but kind of like encourage it, prod it to be minimal. You can also use it to translate errors. We use symbolic tools to confirm correctness. So I have it translate syntaxes, sometimes errors. Like I translate the error or the thing that I think might be causing the error into another language, so I can like run a reasoner over it to see if there's like an inconsistency going on that it's not going to be able to pick up on. But basically, if there's any kind of like, if there's any tool that I know I could use to address some part of the problem, I will use that tool over the LLM, and I will use the LLM as glue to get me over to that tool, whether it be transforming into another syntax or just like telling me how to create a little pipeline to get from point A to point B. So I rely as much as I can on tools that already exist that I know work to solve these problems. If you're unfamiliar with tools that work or could work to solve problems, you can just ask it. You can be like, hey, what tools that aren't you can I use to solve this? And also ask it for multiple possible options. You can also prompt it, and perhaps should, to tell you what context you failed to supply. So again, some are better, some of these LLMs, some LLMs are better at this than others, but you can say, look, here's the problem. Am I missing any context you need? I found that they're not bad at being like, hey, I need to know this, this, and this. So like again, if you're like provide as much as you can to set up the problem so you can get a straight answer, a good one, a multiple potential causes, minimal fixes, but also you can add in, you should feel encouraged to do so. Hey, am I missing anything you need to give me an answer to this? You can also use LLMs to differentiate before and after versions of code or axioms or constraints if you're not following another practice for tracking versioning. So if you've not followed Sane's practice, not introduced like branches and fucked them up and then gone back and fixed it, right? Even so, like it might be a quick and dirty thing to do to just take the before code, take the after, feed it in, and be like, where are the differences? Maybe you don't want to look at all the code. You don't want to hunt this thing down. Just let it do the diff for you. Don't trust it 100%, check, like trust but verify. You can also constrain the LLM to minimal edits and prohibit any semantic changes unless explicitly intended. You can tell it, I need you to fix this or adjust this minimally. Here, I plugged in some code or something. Don't make any meaningful changes unless you check with me or unless I've told you to. So essentially, hopefully you're getting a picture here. There are various things you do, task-related things you can do for LLMs, but also like treat it like a tool that you need to provide explicit guidance for to make sure it does what you want it to do. It's not going to be perfect, but these will help you get a little farther along than you might have otherwise if you're just kind of brute force prompting, be like, what's wrong? Or you just type in like, I keep getting this error on this code. It should be like, can you say more? Right? But you shouldn't trust it to say, can you say more? You want to prompt it and be like, tell me more, what more I need. Provide only the relevant snippet or file fragments to keep the LLM grounded and prevent speculative output. So this is not exactly intention with some of the previous like principles, but like you don't want to give it too much because it's easy for these things to go off on the rails. So give it specific prompting about what to do, kind of guardrail in. Don't like give it your whole code base and be like, tell me what's wrong. It's probably not going to do well at that. Let's see what we got. Create a markdown file. So Sonic's saying you can create a markdown file with debugging instructions that you can paste and have the AI ready every conversation. Absolutely. I have a document where I basically like plug in exactly that. So it follows these principles. I mean, some of these I have to follow manually, but for the most part, it has like prompt instructions, like do this, don't do that, do this, don't do that. And then I can turn them off and on as I want. And with that, here's what we get. So you guys got problems. You guys need some help. Let's do it. You guys need some help. Let's debug some stuff.
I just want to quickly add on the LLM debugging. I mean, I literally couldn't write a single line of code myself without an LLM. So I rely on it pretty heavily. Two, I think, really important practices if you're where I am, like you don't really know coding at all. The rubber duck thing, like having the LLM rubber duck to you so you can understand what's wrong and then question it properly from there, is really helpful. Otherwise, you end up asking a big scope of a question, which might make the answer a lot less more accurate because you don't even know what you're asking.
Right.
That's one thing. And another really important thing I think is you want to give, like kind of like you said, like you don't want to give too much information because it gets confused, but you also need to ensure that you're giving foundational information separate from the code. So let's say we're doing an assignment. If you elaborate in as little words as possible, but as clearly as possible, the purpose of what you're doing and the end result you're trying to get, the model will push in that direction a lot more effectively, I think.
No, absolutely. Good comments, good feedback.
There is one technique, and I'm not completely sure about it, but it's like first try to have a conversation with the AI to create a markdown plan, a markdown file with a plan, and try to break that down in smaller steps until you start to see the picture. And then you can sort of say like, hey, can you give me a proposal for 0.5.3? Can you write me a little function for it? How would that look?
Yep.
But you really need to, for this to work, you really need to break it down till you really understand it. Because anything you do not understand will create sort of a ghost block of code that can go up and down the whole file, your whole code base, and you will not know where to place it. So, and Jeremy Howard does the other way around. He begins with writing small functions. He gives a course in Solve It, and that helps you to learn how to program using AI in notebooks by having conversations and writing only 2-3 lines at a time. It's going now. It costs $500. There's still place, and then you can learn how to code with AI in a way that it actually, because that's his shtick, it improves you. Because there's a lot of people that become less good coders because they start to forget things because they use AI. The biggest rule is don't become worse because of AI.
Right.
You're screwed. It happens. Seriously.
This is good. No, it absolutely does. Absolutely. This is good. I mean, here's some set underlying conceit how I've approached the construction of this class or seminar, which is a little abnormal from what I usually teach or how I usually teach. So this is basically how I learn. Basically how I've achieved things. Struggling, fighting hard, suffering. This is how I've accomplished things. This is why I'm successful, I think, in large part. And I think I am successful in a short amount of time. Kind of climbed up through a trailer park, and here I am, right? Like, it's been like overcoming. Debugging is central to that. It always has been. Like, basically, you're learning in this seminar cutting edge research areas, and you're doing it in a way that I learned and approach and problem solve. And so even if you feel like you're not learning things, even if you feel like you're behind and having like you don't have like knowledge, you can go tell somebody and be like, look at what I learned in John's class. I'll tell you, you get a bunch of know-how, and you'll see that. I do not doubt that you'll see that as you encounter other problems in your life, other problems that you need to solve. You'll see some skills that you picked up for struggling through here and be able to apply those again and again. And for that, I mean, that's the goal, right? I want you to persist and grit and work through it, figure out how it works for you, how critical thinking works for you, and how you can uncover strategies for approaching problems through the hard method. So I didn't spoon feed you stuff. Not at all. Made you work for it. And I think you're doing well. So yeah, good on you. This is not in conflict with what Alex was saying. It's kind of an elaboration. All right, so where are you guys? How the project's coming? We're going well?
Yeah, I was gonna ask. I saw Project 6 was saying that we were gonna present for that project, right? We have to present for that project, at least explain what we did and stuff like that.
Yeah.
So is it 2 presentations that we're having then? One
Nope.
of our choosing, or just this?
So I've just got to basically have the next 2 meetings set up for presentations. So here, maybe I'll just walk through what I'm talking about. So this should be familiar if you're tracking along in the lectures, because I talked about this last week to give you a heads up, but I did post basically what I said in the lecture last time. So you see, yeah, this is the bad boy, right? Like this is it. Final project. He demonstrating how to integrate. In one case, how to expand your semantic pipeline, and the other how to use LLMs to like connect up and make your pipeline or mappings at least more robust. But you'll basically be selecting 1 or 2 project pathways and deliver a live presentation and demo during the final class meetings. That should be plural because we're going to do it for the last 2 sessions. So One of those options is data and design pattern expansion. So you extend your current semantic pipeline, what we did in the midterm, so it can ingest and model new domain, new class of data, or new family of design patterns. So if you recall, we had the information design pattern that I provided, gave you some toy data, gave you some dirty data. You want to add more, but also align it, more of the same sort, and then align it to a different design pattern. You can construct your own. You'll have to just construct your own design pattern to add. It could have something to do with artifacts, presumably, something to do with temperatures or some other metrics or measure. But here you'll be detecting and normalizing unfamiliar schemas, identifying new ontology design patterns, mapping new design patterns to existing ones, perhaps auto-generating Sparkle QC queries and shackle shape constraints, because if you recall, you had to do some of that verification, and then proposing candidate axioms for the new domain. We want a kind of a rich representation, and so I encourage you to add some axioms because we've all been playing with axioms so far to your RDF files. So tools you might use, it's not exhaustive, but you could probably use Robot and Elk, among others. For the reasoning, Shackle for shape validation, obviously, OWL, other OWL reasoners for checking out like logical coherence, Sparkle, GitHub Actions for your CI/CD, and then your favorite LLM or multiple. But it's essentially, again, playing with that semantic pipeline, make it a little more robust, extending it a little bit, and then showing me that you can do that. I would like to see in the presentation that you are able to expand it of your own accord, to take in new data with a new design pattern. I want you to leave with this, if you're following this option, I want you to leave knowing how to do that. So I want to be able to trust that you can go do that, right? Now, I think if I were, let's see, if I were inclined to rank these in terms of difficulty, I think that first option is the least challenging, partly because you should know how to do this already, right? It should be clear, because you kind of have done this. Like part of the exercise was taking new data and bringing it in. And you might be thinking, well, John, we didn't construct a design pattern, right? We didn't spend time in that project doing that. But you did in project 2, right? Like you can basically construct a design pattern. I gave you guidance, but you know how to do that. So like the tools you'd need to solve this are right there at hand, and you've had practice doing them. The second option, I think, might be a little more challenging. Again, if I were inclined to rank these, I don't think too much more challenging, but a little more. But the idea would be to extend a pipeline that uses LLMs to generate, evaluate, and validate ontology mapping. So I think perhaps the most challenging project we had thus far was the mapping one. I suspect some of you might disagree and say that project 2 was the most challenging one. Perhaps, but for my money, the mapping thing was, if I had a priori been ranking in terms of difficulty, that would have been the one that I would rank the highest. Now this second option is extending the project, and I would want you to use LLMs to do that, like to help ease the burden. So generate new candidate mappings, rewriting labels and definitions to aid matching. Producing, and these are some just examples, producing mapping explanations or rationales that can be valuable, some documentation, scoring mapping plausibility. So we've gotten some of that when we're dealing with like MAUL and LLM, like the candidate ranking. So like you're getting a score in a combination of the MAUL outputs and from an LLM. So like, you've seen some of that in project 5. You'd be doing something similar here, suggesting mapping related shackle or Sparkle constraints so that you can validate as data comes in. Tools you might use, again, not exhaustive, OWL reasoners, as well as cross-ontology inference tests to verify correct entailments. What is that? Not a lot of ontologies, very few ontologies have instance data that is used to test entailments. That is very uncommon. It is very valuable. When I am testing an ontology, I usually create instance data, dummy instance data. You've seen me do this. If not in here, then if you come to the 101s, you've certainly seen me do this. If I want to check, for example, that some object property is entailed to be transitive, even though I've not asserted it to be because of various other assertions, I can test that by introducing three things in the domain instances, make sure they're disjoint, they're not the same individual, and then plug those in to the appropriate object property to see if I get an entailment of transitivity across them. I'm not going to be able to check that directly by I'm not going to run a reasoner and have an object property get a check mark for being transitive, right? But I can plug in instance data to see if the appropriate entailments are in fact entailed. That's what I'm talking about. Like, what do you expect to happen from like an inference engine, from a Sparkle query, from Shackle? What do you expect to happen at the instance level? Just plug those in and test. Like, set yourself up with tests. Scoring mapping plausibility, of course. Again, very similar. You use LLM to help with that. And then suggesting mapping related Shackle QC constraints, much like in the previous. Oh wait, what am I doing? I told you I'm delirious. I'm repeating myself. Yeah, wrong list. I should be down here. Shackle to enforce mapping constraints. Sparkle QCs to identify potential mapping errors. CI automation to validate the mapping layer end to end. And then your favorite LLMs, again, tools you might use for this option, not exhaustive. Final deliverable. I want to see in your presentation, tell me what option you picked first and foremost. Explain your setup. Explain your architecture. If it's the mapping stuff, explain your pipeline. Explain how it goes from end to end. Explain your work. Like, what are you doing and how? You don't have to go into the minute details. You can give me like a high level overview, but I want to see a narrative basically for inputs and outputs and testing. Same with the data, the semantic pipeline embellishment. Like that one again is probably easier to explain because I explained it, right? So you can kind of lift on the narrative that I gave you. And I like that narrative. So I will probably like it when you say it too. That's one of the reasons, incidentally, which is why I think the second option might be a little more challenging, because I provided more setup in the first option that you could lift from. So I want to see the workflow. I want you to run it. So I want you to have tests. I want you to show me when you, for example, in the first option, trigger a YAML file. Or trigger a workflow. I want you to see it populate with the outputs, and I want you to open the outputs and check it in front of us. For option 2, I want you to trigger, and I want you to show the candidate mappings, right? You don't have to tell me they're great. We don't have to evaluate thumbs up. I just want to see that it works, runs through, and provides the right outputs or the outputs that you're expecting. I want you to be able to explain how it went from step A to step B and got those outputs. So hopefully in combination between that explanation of your architecture and then that demo, everybody in the room will have a really good understanding of point A to point B, right? And because we'll see the results, they were what you expected, boom, right there. Then maybe we'll quibble about whether it's a good candidate mapping, right? But like we got to get there first. In addition, just verifying correctness with reasoners. So, I mean, some of this is built into the semantic pipeline. Some of this is built into the mapping, right? Like just checking, just look for opportunities to validate your work. Again, it might be easier to see with the semantic pipeline because I laid that out. I laid out some of that for the mapping one, but not in as much detail. So you might have to go thinking a little harder about how you can validate what. And then, as I said, as you're displaying, so definitely display the deliverables or display the output of this. I want you to be able to describe it. So again, this is kind of like summarizing everything. I want you to be able to talk about what's happening, talk about the output, and illustrate or like display competence in what you're showing us. I'm going to ask you questions. I'm gonna ask you reviewer 2 style questions. Just want to make sure I see everybody's face, whose faces I can see. I'm gonna ask you questions. I'm gonna be walking, like listening to you, and I'm gonna be paying really close attention. And if I catch any kind of hesitation in your voice, I'm gonna pounce. It's my nature. You're gonna be like, so just as a pro tip, if you're like, I don't know how this works, I'm gonna be like, noted. Noted. No, I'm not gonna run you over the coals. I don't like doing that. So this is a safe space, so it's okay if you don't know how something works. What I will do though, I will know if you're in that bucket, and then I'll probably say something like in the Q&A or as you're working, let's dig into that and figure it out. So like don't feel like I'm gonna be like, oh, you don't know that dummy. It's gonna be more like, oh, okay. That seems like it's a complicated thing. Like you're not exactly sure how it works out or it's working. Let's talk about it right now and see if we can figure it out. Okay, so definitely safe space for you to like be unsure, but I'm just calling attention. Okay. Like if I note a point in your talk or presentation where like I get the feeling you might not exactly get some piece of the puzzle, that's exactly where I'm going to jump in and be like, let's talk about it. Now, if you get it all, I'm still going to have questions for you. Just, I'm curious, Jeff. But not just me, we're all going to ask questions. So it won't just be me. You'll be, again, sterile environment. For the Q&A is kind of my policy here. Don't be nasty. Don't be mean. We're all trying to support. I don't think anybody here will. I just always want to say it. Like, this is a sterile environment. We're trying to do this well. This is hard work. You probably worked a lot on it. I don't want you to feel bad. You shouldn't feel bad. It's hard. And so I will be attuned and taking account and like doing my best to make sure that we're respectful of each other's work and time and effort that we put in here while we're, trying to dig in some details. So, all right. So, any questions, comments, concerns at staff Taro about that?
This might be asking too much, but since some people were saying when you were gone that like some of the projects, it's tough to even know like what we're supposed to be doing. If we do have that extra week, it might be, and again, I don't want to ask too much, but it might be valuable to have really like basic examples of what our project should kind of look like or how we should run through it.
Oh, hell no.
I figured, but I couldn't hurt to ask. So.
No, it's not weird to ask. It's totally reasonable to ask. It's like, that would totally be antithetical to the purpose of this class.
I figured, yeah.
Like I would do it if this were a different class. I would have walked you through step by step, but no. If you don't know what you're doing, think harder.
One of us had to be the martyr to try. So
I appreciate that. If you don't know it, seriously, if you don't know what you're doing, you're having trouble. You can ask me, obviously. Like I'll tell you some stuff. You can ask other people. You can get on Slack and ask questions. You can poke around, like try to figure stuff out. You can think it through yourself, but like this is hard. The setup is hard on purpose.
yeah, I knew the answer when I asked it, but I still had to ask.
Oh, I know. I'm saying this more for because I wasn't here. I don't know who said what. But this is a struggle class. It's not a weed out class. I don't want you to think that. This is not what this is about. But it is it's kind of a grit and perseverance class. So it's hard on purpose. Believe me, I want to tell you exactly what to do as an educator. I want to tell you the steps. It's kind of against my nature to not, but I'm holding back. My daughter sometimes like does something dangerous and like I want to just like protect her. But sometimes I'm just like, you're just gonna have to fall. And she trips and skips her knee and she's like, oh, my knee, why didn't you protect me? And I'm like, I'm helping you. You don't understand, I'm helping you. All right, who doesn't know what to do? I'll tell you. I can't resist. I'll try not to tell you too much, but all right. Who doesn't know what to do? I'll see what I can do and like maintain my kind of like hands off the approach.
Yeah.
Okay, well, Fede said he doesn't know my Well, okay. If you don't know what maybe another way of putting it, like you're not sure, like presume maybe someone or some of you aren't sure what success looks like. Maybe that's the idea. Like, what does it look like to be done? Like, what's it look like for this project to be good? Is that the idea?
Yeah, I think that's why I said like the sample basic model, so we can at least have like a rubric of what it should kind of look like. Yeah.
Yeah. So like, look at the project descriptions for one. Look at the code. Look at the thing I'm testing. Look at the tests. And each of the projects should have like a rubric style description of what I want you to both know and what you're being tested against. So, I mean, Alex, I think you had the right instinct early on when you were like, I just looked at the tests, like did that. It's kind of a minimal bar. The tests aren't that sophisticated. It's a minimal bar. It's a sufficient bar, though.
And it also, not to cut you off, but also like I wouldn't, now that I'm for my first two projects, I had to just do the minimal to get it in. But now that I have a little more confidence, it's less of a bar and more of like a parameter or a frame of what I should be looking at.
Right. That's right. There's a lot of flexibility in here. And the class was designed this way. I know folks are gonna go in and like go hard on some of this stuff. Like project 2 is a great example. I know the instinct to model. I feel the instinct to model. I know the instinct to model grandly, right? And I know how challenging it can be to hold that back. But you don't actually need to do that much to pass that barrier, right? Like to pass the test. And a lot of folks did a lot more. Totally fine. Totally fine. A lot of folks did that exercise and they learned, something about their inclination to model. They learned something about where to cut off that inclination, right? When it might be too much, when it's taking up too much time. But like, I kind of like left the space a bit open so you could explore that terrain on your own. I could have told you, and in fact, in some of the Q&As, like some of the back-to-backs we had, when I think Alex, you asked me, when do I stop, right? I started gesturing at some like principles that I know or have in mind about when to stop. But I could have told you those things up front, but it probably made a lot more sense after you fought with it. And you're like, oh, okay.
I also think it's good practice for the real world, right? Like you're gonna get a job and then only have so many hours that you have to complete it, and you might want to put 150 hours of modeling in, but it just doesn't make sense for the paycheck you're getting.
Happens all the time. Happens all the time. Or like on project 3, maybe, or what is it, project 4. Maybe you've never encountered messy data. I mean, that wasn't even the messiest data. I've heard tell that some groups, some people who have played with data that have never even encountered messy data before. They were given like clean data to work with. I'm like, that is not how the world works. It's not even that messy of data. I was talking to a friend of mine about this earlier on the car ride in. He worked at IBM and he was like, 3/4 of my data science job was cleaning data. Like just the full 3/4 of the job. It's true. So like learning what it in the in some sense looks like, what it looks like, what you could look for, how to mitigate, how to address, learning how to figure that out, very valuable. Not that you need to go do that for the rest of your life, but now you can probably talk to people a little more competently than you could prior about data cleaning. Or at least it's on your radar. So again, summing that up, success, kind of a minimal bar, looking at the tests. Check out the tests. Also check out the rubrics in the project. Like, this is what I'm looking for. And the learning objectives. You can ask yourself, like, and here's how you can assess me and the project. Look at the learning objectives. Say, all right, did I get that? Did I get that out of this? Just to be clear, right? I'll do one for you. Projects. Project 2. Look at these learning objectives. Leverage ontology modeling strategies to design a small RDF graph, reusing ontology and elements where sensible. This is what I wanted you to learn. Manually construct RDF from raw data using basic design principles. Follow linked data best practices like stable HTTP IRIs and labels and data types. Pass an auto grader that verifies your RDF passes basic validation test. Look at those minimal learning objectives. Huh? Now that you're looking at it in retrospect, I suspect you may have glossed over them very quickly and jumped into the project. But like again, did you learn that stuff? I suspect so. Project 3. What did I say here? Learning objectives. Execute Sparkle queries directly in Jupyter notebooks to explore ontology content. Execute L2 reasoners and debug inconsistencies. Construct and assert translation definitions between ontologies. Construct and assert L axioms based on textual definitions to enrich semantic relationships. Develop competence in debugging code, paying attention to file names and directory structures, reading error messages, and so on. Again, you can assess me. Is this what happened?
One question, John, about the global and local reasoning.
Mm-hmm.
I don't know quickly where to position that in the scope of this project.
Yeah, so I'm thinking this is kind of a Johnism, honestly. I don't know that it's like the terminology is a standard. But when I think of when I'm using global reasoning, I'm thinking of like reasoners, like automated reasoners. This is the way they work. They're like exhaust branches. When I think of local reasoning, I'm thinking of targeted like queries, like graph matching, and select Sparkle, right? And so this was I learned this. I came up with this when I was working with developers who would talk about reasoning, and that wasn't like automated reasoning, and I didn't want to be like that's not reasoning. And so if they would talk about like SQL as reasoning, I'd be like, well, there's a sense in which, and what's the sense? And so I was like targeted versus global. That seemed to work out.
Nice. Yeah. I actually had this conversation indeed. It's Sparkle reasoning, and I thought it was more akin to SQL, like
Yeah, right.
like joins. It's join. Joins are not reasoning for me.
Right, right.
But yeah, it's subtle.
Yeah.
If you try to express it in natural language, it's actually sort of it's weird. It gets weird fast.
Yeah. It is certainly like it's a non-standard use of reasoning. Like I wouldn't say reasoning like if I had my, my actual like pedantic hat on. But then again, I wouldn't say any of these things are reasoning. I'd say there's like inference engines and reasoning is done up here. I'm reasoning, but now I'm being real pedantic.
Fair enough. So global inference and local inference it
That's
is.
right, global and local inference. And if I'm being even more specific, like Tableau reasoning versus graph matching.
Yeah. Inference is, by the way, the same word you use in statistics to infer from the average of a sample, the potential range of the average of the population. That's what inference is.
Right,
so
right.
It is, you take what you see and you try to project it. So inference might actually, in that sense, in this world, sort of like, close to inference in statistics. Might give some synergy somewhere.
Yeah, that's interesting. No, that's true. Yeah, like that. I mean, there's a sense like if I'm thinking of this in the logic space where, I live most of the time, it's like they're strictly like roughly three camps of inference, and it's deductive, abductive, and inductive. So like one is like basically deductive. Do the premises contain the conclusion already? Or are you just sorting it out? And then inductive is the premises do not contain the conclusion, but it's justification anyway, to some degree. And then abduction is best candidate explanation for your premises. Yeah.
Sherlock Holmes actually does abduction and he calls it deduction. Just to
elementary abduction, my dear Watson.
Yeah.
He's not like looking at the piece of fuzz on your jacket and going, it must have been the case as a matter of deduction. Yeah. Then again, he's not doing anything. He's not real. One of my professors here, John Kearns, passed away not long ago. He's a logician, and anytime somebody would ever say anything about like Sherlock or any fictional character, like, well, he does this. Be like, no, he doesn't. He doesn't do anything because he's not real. Like a bug. Then his wife, they would watch movies together, and his wife would be like, "Oh, at the end, I wonder what happened to them after the film." It was over after the couple or after the film, what happened to the couple or something, and the main characters, and he would be like, nothing, nothing, not real. So yeah, same.
One last question from
Say
my
that, but
side.
I'll take them, man. All the questions. It doesn't have to be
Yeah.
long.
But you're also like sort of half sick, so I feel a bit embarrassed.
Oh,
I mean,
man, it's cool.
you should sit somewhere or lie down. But listen up. Let's say I have a definition and it contains more than the actions, and I say, well, just add an axiom. But yeah, maybe I then have to add some kind of class. Can I sort of say, like, listen, for the use of IES, I can just add an action with a class. I'm not going to do a lot with a class, but at least, quote unquote, the main path of IES got a bit better specified. I now got an underspecified path, but at least from the perspective of IES that doesn't seemingly have any rules regarding top down and everything needs to be, it seems like an improvement. Then I don't know if IES works that way. I don't know. I don't think everything derives from a top class, but you get my gist. Now, sort of, I have now in the main path weekly axiomized stuff. I can strengthen the axiomatization a bit, but that leaves a new thing open, which is weekly axiomatized, but still better
Yeah.
from a perspective. Is that a view?
Yeah, I think it's in line, right? Like, so, I mean, again, to me, this is right in line with that strategy I was talking about a minute ago, like that we were discussing, right? Like in my ideal setup, there would be I had my logical druthers. You take IES, make it precise, and then you would project all of it, wherever it went, into the space of BFO. And they just sit next to each other, right? Like they wouldn't be like subclassic, they would just sit next to each other. And then you would have a reasoner or a set of reasoners or tools or whatnot that would like check the structures across and like identify where they overlapped, where they were isomorphic and when they weren't. And when they weren't isomorphic, they would like create projections as far down the hierarchies as they could across like crossways, so that the result would be you could do one-to-one, like basically take the theory of IES and map it directly into an extension of BFO, and the BFO map it directly in the extension. But all that stuff I just said after I said fit these two theories together, like in the same space. Everything I just said after that, my vision is if it's richly axiomatized well enough, can be automated and learned. So I want to learn when these things are isomorphic, but I need those things sitting in the same space so I can put them together like logically and let the machines do that. Like that's ultimately what I think of as the way forward. Not saying there's like a tableau that'll do all that. I'm actually thinking there's this I don't know if you've seen this. It's Calore repository. And my big dream is so Michael Gruninger and his students have been putting this together for years. My big dream is to train some algorithms on this because it's essentially structures, well-defined mathematical structures in Cliff. It's like this is what is this? Approximate point, the theory of approximate points. And then there's a theory of like, there's a theory of algebras, like vector spaces. There's a theory of between the predicate betweenness, whether it's convex or linear. And they're all like all these structures are like related to one another through lattice like hierarchies. And it's like a well-defined, basically massive ontology of logical structures. And like I want to train of an algorithm to like both predict and ontology or like do ontology completion with axioms using this as like my training data. And for that, I think that now I think I'm with that kind of insight, I think I'm in the range of being able to kind of start automating some of what I was describing a minute ago. Like take this theory, put it in the same space of this theory. Now run this machinery to help do some completion and projection, extend the theories, and then learn where they overlap and where they don't. That is my opinion.